Hi guys. So I'm assuming everyone can see my screen. So we'll be looking at luring and monitoring attackers. So exploring honeypots for log analysis and Azure in Azure Sentinel. Just moving on. So just a quick overview before we get really into the nitty gritty. So understanding honeypots. So we'll just look through different types and a real world scenario to draw on. Log collection and analysis. So using Azure Sentinel itself, KQL, that's essentially just SPL. So we had to learn a new language for that. And then looking at use cases for SOC team and just benefits in detection and response. So firstly, what is a honeypot? It's essentially a decoy computer system designed to attract threat actors by making them think it's a legitimate site or like a target server. So it serves as a trap, allowing cybersecurity professionals to monitor and analyze malicious activities. And there's three main types, like I was going through before. So we'll go through them now. So the low interaction honeypots tend to be a little bit less resource intensive, and they can gather basic to almost valuable information. And we'll go into that as to why. So I did build a honeypot for this instance. So it was monitoring failed RDP logs. So similar to, it's this remote desktop. So in Sentinel, it was ingesting these logs to gain geolocation data from an IP address. And we just used a script that would reach out to an external API. So I've got a demo here. Oh wait, yeah. So just a bit of backstory. So ipgeolocation.io, that's the external API that we used. So you can just sign up, and effectively what the script is doing is putting the IP addresses into that little sort of search bar up here, and it will just give you the geolocation data. So um, I'll just divert my screen for a little bit and share with you a quick demo. Hi guys, so this is just a quick demo for the honeypot build. Just looking at the screen here, we have Event Viewer, which is a software that's run on the honeypot itself. I think every Windows has this, but it's just a quick way to view your log data, basically. So what we'll do is we'll go through here and it's logging a lot of 4625, so failed login attempts. And the padlock just means it was unsuccessful. If you see a key in these log files, you'll find something that's more like a successful process. And we'll be able to demonstrate this later on. So just getting out of this, we built a script that would basically take the IP address or the source host and pass it through an external website that grabs latitude and longitude, the state and the country. And here's the script here called log exporter. And this pink text here, that's just, well, it's simulating failed login attempts as we speak. So you'll see the file that's creating failed RDP down here, and you can see that it is incrementally growing just per the request. So it's making like a much larger file, which we're then able to upload to Azure. So literally it's just taking 4625 events, so failed logons, taking it to that website, ipgeolocation.io, and then it's grabbing that data and just sort of funneling it into Azure. Right, so just moving back to the slides, I'll just go over some key findings that we got from that, from those logs. So as you can see, we have latitude, longitude, you got your username here as well, and source host, state, and country. So moving on, we've got the medium interaction honeypots. These tend to simulate more of like a web page, or well, in this case, we were using it to disguise it as a VPN server to confuse or delay attackers, which would give the SOC team a bit more time to detect, assess, and respond to potential threats. For this VM, just because it's meant to be deliberately vulnerable, we did open up SSH, HTTP, and HTTPS. And I did have to secure an SSL certificate for the HTTPS, so I'm really glad I got that. And we were experimenting with arbitrary JavaScript commands to sort of waste a bit more time and go into a bit more stressful situations for the user side of things, like an infinite like hashing loop and like the refresh button. So it would just mash it like a bunch of times. So here's what it looks like. Although if someone does want to legitimately look up the website, they can. So yeah, you would just put in arbitrary username and password, and it would just waste someone's time. Someone's, mostly mine, but someone's time. Um, and then just moving to the high interaction honeypots. So these are designed to engage attackers a bit more in depth than what we've just been through. So there was an instance, Operation Trojan Shield, and it involved the FBI and the AFP monitoring Anom, which was an encrypted messaging app a couple years ago. And a lot of people didn't know, but the backdoor, so the FBI had a backdoor into that sort of messaging app, and they were sending encrypted messages to the iBot servers. And funnily enough, they made sure that the servers were outside of the US so that they could uh, legally obtain that data. But yeah, that led to roughly 800 arrests worldwide in 2021. So it was calling in a lot of questions, the legal and ethical concerns about that. And just moving on, I'll hand it over to Brad now.
All right, so my turn. Um, what is Microsoft Sentinel? Microsoft Sentinel is a cloud-native security information and event management solution specific to Microsoft Azure. Like Splunk, Microsoft Sentinel can be used to collect, monitor, analyze, and respond to possible or true security threats. Alerts, dashboards, and custom query searches are accessible too. So this is what our environment actually looks like. So over here, we have our asset side. So this is this is what we want to keep safe. Like Project One, we had the jump box, and then we could get into the VMs from there. It's set up very similar. Over here, we have theoretical attack devices coming through. This is the VM from the demo, and this is the VM from the VPN server website example from the slides. Log Analytics Workspace. Log Analytics Workspace is a powerful tool within Azure that allows for collection, analysis, and visualization of log and performance data from various sources. It enables us to query large volumes of data using KQL, making it easier to uncover insights and detect anomalies. Custo query language. KQL is used for querying and analyzing large data sets in Microsoft Azure. It is primarily employed with Azure Monitor, Log Analytics, and Azure Data Explorer to handle log and telemetry data effectively. Data analytics. In our case, we can see multiple benefits to implementing honeypots into a network. Minimal false positives since any interaction is likely malicious. Isolated from normal traffic, causing no performance degradation. Depending on the nature of the honeypot, offer details logs for post-attack and analysis and legal action. There is potential for employing several hacking TTPs when implementing the honeypots in your network. So now I'll quickly go over to a demo, going through just some search queries in our dashboard. Hey guys, so I'll take over and talk about the Microsoft Azure environment for a second. I'll run through a couple of things because we won't have enough time to go through everything, but I'll do my best. So as you can see here, we've configured and all of our environments in Azure. So Jumpbox, VM1, VM2, and a couple of honeypots in there. So if we move over to the Log Analytic Workspace, Law Honeypot 00. This is our Log Analytics Workspace for our Windows honeypot. So let's input a simple search query and run this. So we get some feedback. So let's just open one up. So here, like Splunk, we get extra information about it all. The source IP, what event it was. So you see activity 4625, an account failed to log on. You get IP addresses, the port that was attacked, and lots of like even different information down the bottom here. It's quite a lot to look at. So from here, we can save it to a dashboard. So we would click on Pin to Dashboard. In this situation, we would click Shared because it is a shared dashboard between me and Lachlan. And we would click on Project or Dashboard as that's what the project's called. So now this is the dashboard itself. Starting from the top, we have auto refresh feature, which it is what it sounds like it is. We can change the time intervals that it does it. So, let's say we change it to every hour, and now every hour the page will refresh, all the results will refresh, and new data will be inputted. And the same as, time range, and we can do time zone as well. I have inputted my local time zone because, well, my time zone. So at the top here, we have top 10 resorts by account type on this donut chart here. And then we have just a random clock because I felt like it. Moving down, we have virtual machines count. So we have 5 machines on the environment. And this is also the 5 machines here as well. So we can view them by name and where they are in location. We have the 4 machines running Linux, and then there's 1 running Windows. And then this is the total hard drive space across all of our environments or machines. So, and you can see here that we have 5 hard drives attached in the environment. So here is more of our custom dashboards. So here we have done a search query and searched for IP addresses that have logged on successfully. And here you can go through and look at the IPs. And let's click it. Let's click on this one. And that certain IP has 913 successful logins over the past 3 days. Next to that, IP addresses resulting in failed logons. So this should be showing as event ID 4625, but for some reason it keeps putting in a decimal and a K, and the same as the count. So let's go down one. IP address 103.165.86.8186 triggered event ID 4625 912 times in the last 3 days. Going a little bit further down, we have this chart. This is the top 5 event IDs triggered over the past 3 days. So the top 3 we have is a new process has been created, a process was allowed to run, and an account failed to log in. And obviously, when you change the local time, go to 7 days, the results will change. And here we have a little bit of a geolocation. So we have username, source IP, state and country. And if we go back the other way, we do have their longitude and latitude. So we weren't able to figure out if we could implement it to a geo map. We just simply ran out of time with it. So we just decided to leave it as this to show that, yes, we have done it, but we just didn't quite get as far as doing the map. But for now, I'll leave it back to, we'll go back to the presentation. Which actually means that's the end. Thank you, everyone.